All right, welcome everybody. It's Hugo Bowne-Anderson here, head of DevRel at Outerbounds. Very excited to be here today to have a fireside chat with Jacopo Tagliabue about reasonable scale machine learning and how the long tail of people who need and want to do machine learning and can derive value from it can do so when you're not a FAANG company. So we'll get started in a couple of minutes, but I'd really appreciate it if you said hi in the chat. Let us know, that chat on YouTube, let us know where you're watching from and what your interest in reasonable scale machine learning is. Okay, we'll get started in a couple of minutes. All right, everybody, we're going to get started in a couple of minutes. I'm Hugo Bowne-Anderson from Outerbounds, and I am very excited and slightly nervous, but very excited to be here with Jacopo Tagliabue to talk about reasonable scale machine learning and how you can derive value from machine learning if you're not Google. There's a joke in there, of course, but the idea is that we're seeing a new space emerge of reasonable scale machine learning in which a lot of value can be derived from ML, which isn't necessarily for FAANG companies. And we require different models. We require different tools, different division of labor, different workflows, different ways of thinking about how to derive value from machine learning. And that's what I'm very excited to chat with Jacopo about today. Please introduce yourself in the chat. I can see Martin from California. Hey, Martin. Jose from Sydney, Australia. That's fantastic. I'm also in Sydney, Australia. We've got someone called First Last from New York. This is actually this is the holy trinity of my life, geographic life currently. I am in Sydney, Australia, but I'm about to fly to California and then to New York. So welcome everybody. Well, look, we were slated to start now. I was going to wait for a few more people to come on in, but I am far too excited to wait any longer. So without further ado, Jacopo, would you mind sharing your camera and we can get started?
Of course. Ciao, guys. Ciao, Hugo.
Hey, Jacopo, how are you, my friend?
Very well, very well. Thanks so much for having me. And also 10 out of 10 for Italian pronunciation of my last name.
Tagliabue.
But that's perfect. I know we rehearsed it, so like you're kind of cheating on this whole thing. But honestly, it's like one of the best Tagliabue I've ever heard in my life outside of my country.
Oh wow!
So that's
well,
really
I'm blushing under this beard. Also, little known fact, can you please tell us all what Tagliabue means?
It means ox cutter, like, you know, the guy
the guy that cuts the ox. Yes. There we go. And we have a bunch of people, and we've got people from the US, from Australia, from Sydney, from Melbourne, from Austin, Canada, Colorado. We have people also transitioning into ML, which is super exciting. Yes. I think it's actually really nice to have a conversation. We haven't even had it yet. It's really nice to have a conversation about these types of ideas for people transitioning, so that they're not necessarily overwhelmed by like the world of what Times Square tells you about machine learning, essentially. Yes, right?
Absolutely. I'm also flattered that people choose to listen to this instead of watching the Roland Garros, because Nadal and Djokovic are playing. So you still have time to to switch channel if you guys want to. But if you want,
you might be watching several screens.
That's also a good point. But if you want to stay here, like I'm really happy that we got to spend some virtual time together, and I hope it will be useful for all people listening.
Absolutely. So definitely thank you all for joining. And once again, let us know who you are in the chat and what your interest in machine learning is. I'll just say something about Jacopo. Jacopo is Director of AI at Coveo, where they combine product thinking and research-like curiosity to build better data-driven systems at scale. And we're going to hear a bit more about that. I'm Hugo from Outerbounds, and we work on kind of related things, right? We work on infrastructure and productivity tools for data scientists. And we want to allow data scientists to focus on building models, doing data science while having easy access to infrastructural layers like compute, orchestration, versioning. We're doing this through something that I know is close to your heart, Jacopo, the open source framework Metaflow at the moment. And we're also working on products among many other things. So I'm going to give a bit of an intro, and then I'm going to step back and we're going to riff. For context, machine learning comes in a lot of shapes and sizes, but a lot of the conversation around tools, techniques, division of labor is dominated by a handful of companies, the Times Square of machine learning, we can call it, who do machine learning at scale that nobody else really needs to, right? There are so many forms that companies outside of these big tech companies can take, but a really interesting, growing, and important segment that is relevant for ML systems is something that you and your team has coined reasonable scale companies, which is what we're here to talk about. And this means reasonable along several axes, right? Monetary impact, team size, data volume, compute resources. So today, what we're going to get into is talk about what such machine learning actually looks like for businesses and practitioners, and what all of you can do to get started with reasonable ML today. So we're going to talk about what type of companies can benefit from reasonable scale ML. Hint, most can. What types of data, tools, and talent you need in order to build a sustainable machine learning function. And also discuss barriers to entry and all the paper cuts, how you can get started today, and industry trends that will help you in your machine learning journey. So that is definitely, oh yeah, if you like this, hit subscribe and share like below. Sit on that side. Hit subscribe and share with your friends. But all that having been said, Jacopo, I mentioned you're Coveo, Director of AI there now, but I'd just love a bit of introduction into you, how you got into data, and kind of what led you to think about these things.
Of course. So perfect introduction, by the way, much more serious than the one that I usually give about myself. So I'm now at Coveo. I joined Coveo through the acquisition of my own company. So I was the founder and CTO of a startup in San Francisco called Tuzo. And if Coveo can be considered a reasonable scale company, Tuzo was a very, very reasonable scale company. It was a small startup doing NLP and information retrieval for e-commerce. And it will come in handy, all the experience, all the mistake and the stupid stuff that we did at that time came in handy recently in the all reasonable scale team because we kind of want to evangelize the field of not doing the same stupid thing that we did, because we kind of already did them. So there's no need for anybody to do the same mistake, and kind of learn from our mistake and kind of, do it better with all the ecosystem that is possible today. So definitely my startup experience, I think, has been super useful. If you guys may have heard my, the misfortune of hearing my Italian accent already before the podcast. So if some of the people listening really like, fancy and slightly pretentious conferences full of academics, I sometimes go there. Me and my team publish a lot, especially in e-commerce tech. So we are really heavy practitioner on ML and NLP. So everything we're going to say today, they're not limited to just building ML product, but sometimes they also translate into how to do ML research. Like cutting edge ML can really be done in many different scales. And of course, especially in the last 6 to 9 months, we've been spending a lot of time doing open source in the MLOps community. We build the Metaflow cards with our friends at Outerbounds, and done several other contributions. And so hopefully all that experience will be useful for the people listening now.
Absolutely. And actually a bit more context. When I read your reasonable scale posts on towards data science, I was like, I really want to talk with Jacopo, and I pinged you on Twitter or LinkedIn or something. I'll put those links in the chat at some point, as the other point, I think you've got a lot of educational material out there. You've got a beautiful GitHub repository. Well, you've got several, but one I like is called "You Don't Need a Bigger Boat," where it's essentially a project around full stack machine learning using a bunch of interoperable tools. So we'll post that there as well. But just quickly, if anyone wants to connect with you or follow you, you've got a lot of upcoming talks coming. So is LinkedIn a good place for them to
LinkedIn is, yeah, I'm very easy to reach anyway. LinkedIn is a perfect place. If you're on the Outerbounds Slack, I'm very easy to reach there as well. If you're in the MLOps community Slack, I'm there as well. But yeah, LinkedIn is the, let's say the best venue
yes.
to connect and see also all the papers and work and repos and stuff.
Beautiful. And thank you for mentioning the Metaflow community Slack as well. I'm going to post a link to that in the chat also. And we'll be having an AMA with myself and Jacopo for the next week or so. It's going to be async, but if you want to join, we've got a channel called AMA Guests, and you can come and chat with us there. And I mean, I think Slack's probably the best way to get in touch with me with these things as well. It's the highest signal place anyway. I don't get recruiters reaching out on Slack. There are a lot of VCs though. Yeah, exactly. Just imagine. Great. So, I mean, we could talk about recruiting and venture capital, but we're here to talk about reasonable scale machine learning. So perhaps you could just tell us a bit about what this term even means to you.
Absolutely. So when we started kind of like putting together these educational materials and repos and code, we found out like a gap in the ecosystem. That is like the metaphor that I usually use is, is about tennis, as you probably guess. It's like if we're all trying to, to be a bit better playing tennis, to learn how to play tennis. And then the only materials that we have available is like, Roger Federer training drills, which are awesome and they're super inspirational. But this is not exactly what we need to start playing tennis for several reasons. First, because we don't really know how to do anything and we just want to get started. Second, because even at the limit, the chances of any one of us becoming Roger Federer is actually not that high. And of course, that's not how you learn playing tennis. Like if you're me, you go to a teacher that explains tennis at your level, right? And this is common sense. And so the question is, why a lot of the ML community doesn't really work like that? So you go out and there's Google did that, and Facebook did that, and Alibaba did that, and Amazon did that. And again, and it's all good and amazing and inspirational. And if you come to one of the fancy and slightly pretentious conference that I mentioned before, there's a lot of this, and it's super awesome. And there's a lot of things you can learn from these companies. But at the end of the day, when you come back and do your day-to-day job, a lot of that is not immediately translatable to what you need to be effective in machine learning. Mm-hmm. And this is, of course, at first I was kind of like, oh my God, these are the only people that can do it then. All of these incredible things are just, just for a few companies unheard. But at the end of the day, all these problems in our view becomes actually opportunities. So it's kind of liberating the fact that you don't have 2 billion users to support at the beginning. It's kind of liberating the fact that you don't have thousands and thousands of engineers to coordinate. And so the reasonable scale is kind of the idea that even with a small team, especially for people starting up in ML, if you start up with the right tools and with the right mentality, exactly like playing tennis, like if you get the fundamentals right, you can go a long, long way to get value out of that. And so we started this, this repo and, a bunch of blog posts and talks to say, hey guys, we think we didn't really figure it all out, but we think we have some recipe and some principle that can help most of the people outside of big tech to actually be productive in ML. And this is what we propose. And of course, open to feedback and open to, to discussion, but this is what really worked for us. And there are principles before tools. And then of course, tools follows in how they best implement this principle.
Fantastic. That's beautiful context. And I mean, you've got the battle scars as we know. So I'm interested to hear about those. And I do want to start drilling down into what reasonable scale actually looks like, what type of dimensions we need to consider. But I suppose for slightly more context, maybe you could tell us a bit about what type of companies you think need help with reasonable scale machine learning.
Absolutely. So like if you consider like two big dimensions, one is, the kind of like, sophistication of like, in tooling ML and so on and so forth. And the other is, the dimension of the company. So you have on the top right, you have like, the Netflix, the Amazon, the Google of this world. And of course, they, they kind of already figured it out. Like my LinkedIn feed is full of, the Gartner report saying that 80% of project never goes into production for ML or something like that. And this is definitely not the case at Google, Facebook, and ML. So these people don't need help, to be better at ML. But then there's people who run a small startup, like the tools of this world, like my previous one. These people actually know what they're doing in the ML side. They're on the very sophisticated spectrum, but they're a very small company. They don't have this much of resources that they can devote to build their own infrastructure or, scale their own tools and so on and so forth. These people are at reasonable scales because they will benefit a lot from the basic principle reasonable scale. Focus on what matters for your company. In our case, was NLP, and basically buy or use open source to do everything else. Okay. Don't devote any resources, any time, any thinking to think that you can just get off the shelf somehow. And then there's another big part of this, which is big companies, but they're maybe behind a bit in this whole ML journey. Think of like a gigantic, multinational company. They may be super successful in their own regards, but they're not a tech company first. And so inside this, you have like startup team, small team of data scientists that are tasked with building this culture of data and this culture of results of ML. And we think that these are also people that will benefit from the reasonable scale principle. Because if you start up in a company that doesn't have a huge tech culture, trying to build infrastructure or try to maintain a huge tech system is really a recipe for disaster. What you should be doing, and I think we're going to discuss this more, is do exactly what producer Y, whatever it is, whatever value it is you want to get out of this, and then surround yourself with tools and products that allow you to go to that as fast as possible.
Yeah,
you can always
absolutely.
You can always go back and say, okay, now I want to internalize this infrastructure. Now I want to redo this. But at the very beginning, what really, I think, stops a lot of project is the lack of this fast feedback loop between when you start doing ML and when you see that in front of your customer, that is internal or external customers.
Yeah, so that's all fantastic. And I want to get drill down, but I've got more questions come up before we get into how to actually do reasonable scale. I do want to read some of your words to you, because I think this is super key to what you just said and how we're going to proceed here. In your first post about reasonable scale ML, you wrote, "This is the idea at the heart of this series can be stated concisely. To be ML productive at reasonable scale, you should invest your time in your core problems, whatever they may be, and buy everything else." Okay, so maybe you can tell. I mean, that's easy to state, but I suppose it has wide-ranging implications for what happens in an organization, right?
Absolutely. So let's start with something that I've seen happening in many organizations from our vantage point of view of B2B providers. Okay, and then we go from what doesn't work to what works. So a lot of time, organization says, well, we need to set up a data practice, an ML practice, whatever, because everybody's doing it. I don't know, Harvard Business Review said we need to do it, or whatever. Investor wants to see it, and so on and so forth. So they take 20 people that may be really good at PyTorch or whatever, modeling, and then they put in a room and say, do something magical about data science. And now, you go back after 6 months, and the only thing you have is like notebooks that don't talk to each other. People keep on, spend their entire time, fiddling with data. Nothing is reproducible. Nothing's the light of day. Gartner says 80% of, product ever. Like that actually happens way more than people think. Like a lot of products don't get into production in the ML side because we didn't really set up these people for success. Okay, so let's rewind this, and instead of hiring 20 people at day one with no tooling, let's rewind it and do it at reasonable scale. So let's say you're building a recommender system or whatever, like just for a second.
Yeah, nice example. We love recommender systems.
Everybody knows recommender system. So like if you have your data into a data warehouse, or you can just buy, for example, Snowflake or whatever, Redshift or BigQuery to host your data scale. So now you can query your data and you don't really have to worry about scaling up your querying infrastructure. And then you want to do some modeling, and you can either use some off-the-shelf tool, or you can build your own model, but don't orchestrate yourself or set up your own GPU. You can use something like Metaflow, for example, to orchestrate all of that for you. So now we remove even the orchestration and basically spinning up GPU and scaling that training part. And finally, you need
Would you
to
mind
serve
just telling people what Metaflow is?
Yes. So
I'd love to hear from you.
maybe you're better than me at this. So
It's a trick
Metaflow
question.
is an open source framework originated by Netflix and now maintained by Outerbounds. That is aimed for people to organize and orchestrate their machine learning project. And it's so great for us because A, it's pure Python. So it allows us to work in the language of data science and machine learning completely naturally. And B, because it abstracts away all the infrastructure needed to run, scale, and then schedule our job. So right now, you basically have in a Python project, completely self-contained, all in Python, everything you need to be productive when you do ML project. And it's a life-saving. And it's a life-saving exactly for this reason. That now I don't have to have a DevOps person or, like a data engineer that is actually just there to schedule my job, check when something is wrong, or to provide me with GPUs. I can just use Metaflow, and Metaflow will do that for me. And for deploying is the same. Like start with some AWS, SageMaker or Seldon or whatever you want to use. But at the beginning, by just stitching together this product, a very, very small team can build your recommender system, push it in front of user, and then only then you evaluate how is it going? Is it going well? How much is the ROI? Do we want to invest more on so on and so forth? Instead of upfronting the investment in people, time, and resources by building something like your Google, which you're probably not, do it gradually. And the way to do it gradually is focus on what matters, buy the rest, because you can always go back and undo what you buy and internalize it later.
How should people think about open source versus, I suppose, vendor proprietary products in terms of adoption?
We do both, honestly. So we do both. We for example, Snowflake is a good example of a product that's a vendor. It's not available in open source. So that's the only way you get it. There's product like Metaflow, open source framework like Metaflow, which we of course use. And then there are hybrid. Let's say, for example, stuff like Prefect, which is available both in the open source, but also can be available as well. So we kind of have all the spectrum. My particular choice is always if there's some maintenance involved, and by maintenance I mean keeping these things up, scaling it up, and so on and so forth, buy first. Because again, scaling stuff doesn't add any value to your business per se. Like my clients want to have recommendation. They don't care how many GPUs they have or how to obtain the infrastructure. The only thing they care is good recommendation. Okay. And I want to provide that. So if the biggest value for me in all this product is typically abstracting away, these low level details and keeping me at the functional level. So that's how I typically decide. So even if there's a product that is open source, but now I need to maintain it myself or like having up and running myself, if the cost is reasonable, I would probably opt for buying the SaaS version.
That makes sense. So what does a company need, and individuals or ICs and teams need in order to get started with reasonable scale machine learning?
So I always say that great machine learning product or research project are basically the sum of three components, like data, tools, and people, right? And it's kind of in this order. Meaning that data, sometimes we forget that, data is kind of, where everything starts in modern machine learning and AI. So if data is not good, meaning that the quality is not good, meaning that maybe the quality is good, but the data is in a place when it cannot be easily queried or manipulated, or, or maybe the data can be queried, manipulated, but nobody knows what it means because there's no domain knowledge. So if we don't really become one with the data set, that's basically impossible to be good at your job. That's at least my experience. Like, you're as good as an ML engineer at the end of the day, as much as you understand your data and how it's used. And then the second is tooling, as in you can have the best data in the world, but then if you still rely on old tooling or, or nothing works, so now you have to ask 3 DevOps person every time you need to do a training loop, you're never gonna get anything done. And then finally, of course, is people, and by people, it means, a combination of like, the right skill, diverse set of skills, experience, talent, and so on and so forth. So all of 3 need to be in place for you to be great. As for, what the bare minimum you need, just think about the main functional parts the machine learning pipeline. So there's the data part, okay? So like querying data, extracting data, cleaning data, preparing feature, the training part, and then the serving part. That's really the bare minimum. Without these three things, we don't have a machine learning project, it's something else, okay?
Yeah.
And these are the three things that you need to figure out at the beginning to get something out of the door. Once that is working, you can start adding complexity. Maybe experiment tracking to be more proficient in your, in track what you do in training.
Data validation early on.
Data validation with, like exactly, or monitoring. Because, after you see something to production, you actually should check what they do. And there's an argument to be made that monitoring machine learning system may be slightly different than monitoring standard software system. And so on and so on. But like, without the three basic components, you don't get anywhere.
Yeah. I've actually seen a question from Brian Case. He asked, can Metaflow be deployed locally, or does it need a cloud? It can be deployed locally. I'd be interested in how you think about this, Jacopo. One of the things I love about Metaflow is it can be deployed locally, and of course you can access cloud infrastructure using it. One of my favorite things, of course, is when I'm building my machine learning workflows, I can run certain steps in my DAG locally. And then if there's a particular step that requires GPUs or some cloud instances, that type of stuff, I can send those steps up to the cloud and store all my artifacts from everyone on S3, for example. Is that one of the ways you think about the power of
that's perfect. That's perfect. I love about Metaflow because it lets me, since a machine learning model is really a combination of a model, but also data preparation and code and so on and so forth. Like a model is really a tiny piece at the end of the day. I love Metaflow because it kind of enforces good practice through this enjoyable coding experience. So now every part of this functional thing is one function. And for each of these functions, I can decide how it run, like, what are these dependencies and where it's run. So to go back to the question, every time you have something of a function in your Metaflow DAG, so in your workflow, you can tell, I want this to run locally. I want this to run on the cloud. I want this to run on the cloud with a GPU versus 20 CPUs or so on and so forth. That's actually the magic of Metaflow. The code stays the same, and then you can decide where and how to run this code, which is amazing because it doesn't require any, DevOps person to do.
Exactly. And so please do ask questions in the chat. We may not be able to get to all of them. And if we don't get to your question, firstly, my sincerest apologies, but you can join, post them in the YouTube chat. You can join our community Slack, and I'll put the link in the chat there, and we can chat about it afterwards as well. So Jacopo, I'm interested in learning a bit more about how we can think. You've identified certain key dimensions that we should think about reasonable scale machine learning along. So the axes of monetary impact, team size, data volume, compute resources. Maybe you can just give me some heuristics or ways that you think about these types of things and why these are the important ones.
Absolutely. So first is, like jazz, is very hard to define reasonable scale as a definition. You kind of know where you see it in some sense. But then statistically, again, outside of the biggest company on the planet, most people will actually do like ML at reasonable scale. In fact, even inside some of this company, like Google or Netflix, there are many use cases that are internal that are actually qualifying probably as reasonable scale, even at this gigantic company. So think about the data part, for example. Like, so a typical use case for a company reasonable scale, like Tuzo or Coveo, is going to be in the terabyte size, which is, quite a significant amount of data, but it's not like, a petabyte of data or whatever that Uber ingested, right? So it's a lot of data. So it's enough data to get a lot of value out of it. But it's something that, for example, a modern tool like Snowflake or BigQuery can easily crunch for you in a reasonable amount of time. So it's still manageable. Of course, on the monetary side, how big do you think that this ML feature you're developing is gonna how big of an impact is gonna make, right? And if you think of the usual example again that you see in conferences or in press, like Amazon is investing a lot in whatever recommendation system. Of course, 1% of increase in accuracy of recommendation system for Amazon translates in probably the GDP of a small country. Okay, but that's really very few companies that have this incredible uplift.
Well, arguably, Amazon is a large country in
probably
net state. Yeah,
and most use cases of ML are not like that. It doesn't mean they're not useful. They may be super useful, but they typically may impact your your top line or bottom line depending on what is the use case, but it may be by tens of millions or or something like that. So it's still a very good uplift, and still like a lot of money on the line, a lot of value, but it's not this humongous kind of imbalance between the accuracy of your gain in the model and what you make. A corollary of this very important fact is that your incentives as a machine learning person are very different when you work at reasonable scale versus humongous scale. At reasonable scale, the marginal gain is probably going to be more in your data than in your model. Meaning that getting better data, getting more accurate data, getting a better engineering, more accurate tooling, and so on and so forth, is going to pay off massively more than a slight increase in accuracy that you can get by, slightly changing an architecture and so on and so forth. Which is obviously not true, again, at the humongous scale, when small tweak in architecture may result in, an incredible monetary gain. So by shifting our attention to this, kind of leaderboard, accuracy fetish of hey, my model is slightly better than yours, we kind of go back into this very practical and pragmatical approach. Well, what matters is, being reliable. What matters is knowing your data. What matters in, being able to satisfy a use case, for your clients, more than just, like a symbolic number in a table, in a paper or something like that. So that's definitely to consider. And finally, I think the most intuitive one is the number of resources that you have, which typically may be in compute. As in reasonable scale, people like us, of course, we use a lot of GPUs, but we do not own a cloud provider like Amazon does, like Google does. And correlated to that, the people that you can devote to this, right? Of course, Google and Amazon have tens of thousands of engineers or whatever. Other people may just starting up with ML. But again, this is not bad. Small teams, when they start up, may actually be exceptionally productive in doing ML if they make the right choices.
Can I ask? I'm just wondering, are we that compute limited? I mean, I think the answer is yes, but we're kind of in the limit of elastic compute, serverless now, and also startup credits. So these three things
good point.
Combined, right?
In ML, I think if you're not doing deep learning right now, and you're in the terabyte scale, I think you're probably right. You can get very far even with a reasonable cloud bill. However, if you're doing deep learning and with slightly big model, like our latest paper in multimodal learning, so kind of clip fine tuning and so on. I mean, honestly, when you start running a bit of experiment, the kind of build kind of piles up pretty quickly. It's not, it's not outrageously big, but it's something that a normal company would want to keep, to some extent under some sort of budget constraints, or you want to keep an eye on it. That's my point. But the good thing about, I think, reasonable scale is that if you do your data preparation and aggregation right, you typically don't need to have much distributed computing downstream. Okay, because at the end of the day, if you have a big enough box in AWS, or you run Metaflow, from your laptop and /AWS, in our experience, you can train fairly sophisticated model without needing that much of infinite compute at your finger.
So we have a couple of questions in the chat, which I think are fascinating. And one of the reasons the questions themselves are interesting, but what they point at is interesting. One is about data quality and size. The other is about how we can think about hardware. I want to get to these questions, but I also want to make clear how overwhelming, these are just two questions, right? About data and hardware. We also have questions about compute, about orchestration, about versioning, about model registries, about code quality, about feature engineering, about maintenance, about deploying to endpoints. So before we get to these particular questions, how on earth is any one person or org expected to get their heads around this entire, complex system? Well, at least complicated, perhaps complex.
Good point. The truth of the matter is very hard, and I think the best answer is you need to go in step. You need to go in baby step. First, you need to start from people, if possible, of course. You need to start from people that already did it before, and they kind of understand this end-to-end thing to a certain level, of sophistication.
Great.
I think one great thing that I take away from my from a startup experience on the tech side, there are many other things to take away. But from the tech side is, since you did the entire thing from data to training, to deploying, to model, to product, to sales calls, to like literally everything, to talk to investor, everything that they need to do. I may not be the best SQL person in the world. I'm really far from being that. I'm definitely not the best model person in the world. I'm really far from that. But I kind of know enough of all of this thing to know all the pain points that people in these roles have. And so I think that was, coming to Coveo, of course, a much bigger company, it was an ideal situation to kind of be able to talk to different tribes and kind of say, hey guys, bear with me, but I know how these pieces fit together. So I think this kind of expertise is good to have, honestly. But the second thing is that this expertise is not a substitute for understanding that the particular, constraint of your company or use cases and so on. That's why I'm saying start in step with the things that you need for sure: data, training, survey. Okay, and then you can build on top of that. And when you start in step, try to write the least amount of code possible and to invest upfront the least amount of resources possible. Ideally, almost none. Okay, because if you are at this point of starting up your ML team in 2022, or if you're starting up your journey, again, you may need that. You don't even know how much ML is going to be important for you, your company, your team. Start small,
totally,
and you can always go bigger. Don't do the opposite of like make a huge investment front, and then in 1 year you get disappointed by that. Executives are like super unhappy, and then everything gets kind of like, teared down as like, oh, this ML thing doesn't really work. I mean, maybe we did it all wrong.
I'm hesitant to go on this slight tangent, but there's something in me pulling me in this direction. So when we're talking about trying to get as much ROI and creating as much value, particularly if you're a reasonable scale company, you need to make sure everything you invest in does deliver value. You can do experiments maybe that don't, and then you get learnings. But if you build out entire functions that end up not delivering value, we know what happens then, right? And it's ugly, man. So my question is, are there companies that shouldn't even be thinking about ML? Like, is ML an initiative that may be too expensive at some points to even invest in? Or do you see things like recommendation systems, search, these types of things being, or even lead scoring, right? There are a few things I think that perhaps nearly all types of businesses could derive value from with small investments in ML. So the question is, to ML or not ML? That is the question.
So ML, I think ML, beyond the hype and beyond the old thing, is really here to stay. And I think ML really promises to improve our life in a million different things, a million different things. What I don't think, and I don't suggest to all companies, is to build their own ML. I think there's reason for everybody to have ML in their professional life to some extent, like the lead scoring, like a lead score. If I'm a salesperson, I want a lead scoring system.
Seriously.
But that doesn't imply that there's somebody on the same payroll that I am is going to build this. Maybe I can just go to a vendor. There's a million good vendors doing this, and I'm just going to pick a vendor that helps you that. So ML is going to be part of my life through an API or to a third party. And that's totally fine. Because at the end of the day, you're focusing on what matters. You're basically doing the principle of reasonable scale. You're focusing on what matters, which is selling stuff, and you're kind of buying something that allows you to do that. Okay, so there's nothing. I mean, my company before and the company I work for are companies providing, as you say, a recommender system for people that for whatever reason need one, but they don't want to build a function to do that, which is a totally reasonable thing to do. And I think a lot of companies should probably do that. The reasonable scale MLOps thing is for companies that are kind of the next level of this. Is like, no, I really want to own this. I really want to internalize this. And then the next question becomes, okay, but if you want to do this in these baby steps. Again, don't build the entire function without even understanding where you're going. I think there are some cases in which it's clear that you want to own things. If it's something that is very related to the core of what you're doing, if it's something that you believe is going to create a lot of value, it makes super sense for you to start investing in it. But in other cases, if it's something just tangent to your business, just buy a vendor that does it, and that's it.
Yeah, that makes perfect sense. So these particular questions, there's a really nice one when we're talking about reasonable scale machine learning from Kevin Maratz. How can small startups produce competitive models when it's all a matter of the amount and quality of the data set how can they compete with the big players in tech? I think we've spoken that to a bit, that, you know, when doing lead scoring, it isn't really, you're not in competition with Google around that. You have different types of data, but it is a kind of good question, I suppose, with respect to trying to disrupt certain parts of the space and these types of things.
So very, very good question, Kevin. So I'm going to answer on ML as a product and on ML as a research. If you want to have that answer as well, please ask a follow-up question, and I'm super happy to do that. So what the super big companies do is typically great for them as a B2C product. For example, YouTube is a terrific recommender, like is an incredible recommender. But that doesn't mean that when you go on Google Cloud, you're going to buy that. Okay. So there's a lot of room for smaller company like, you know, Tuzo, Coveo, or like other company in the space to really understand the use cases of when people need recommendation system. It may be, you know, in a customer service portal, it may be in an e-commerce and so on. And that's the understanding of how the use cases, the data and the model fit together that sets you apart from generic model that big cloud provider have. There's a lot of, actually, there's a lot of space for startup and smaller company to really own verticalized example of machine learning, where machine learning is used for a specific context. And your power is to be so good at that data, that type of data, the type of use cases, that you know exactly how to build it. If you want to do a full out competition, a general model against GDP3, you're going to lose. But also that it's kind of honestly a pointless thing to do. Okay. But if you go narrow, you're going to find out that you can do something better than GDP3 by fine-tuning model to your exact use cases. And that's what your value as a company. The whole idea that models are per se like a competitive moat is most of the times not true, because A, people catch up very quickly. So it's not super defensible to continue this innovation cycle. Okay. And B, because at the end of the day, if you're building a company, the marginal gain, again, that you get from a slightly better model, it typically doesn't compensate for other things that a company may have, like a great market fit, or, you know, like incredible support, or like a better UI or something like that.
Fantastic. So I want to get to the hardware question. I do want to just foreshadow, Shang Ong has just said, I understand reasonable scale is all about rethinking companies' ML processes. Could you move into how to actually doing it? We're going to get to that in a second, but I love that. Of course, this is where the conversation was going, but I love that people here are feeling kind of the impatience that, well, I didn't mean that as a pejorative. I'm impatient. I'm excited to get that. But just before we get there, Michael Neely has a wonderful question. This is the hardware question. How does ML hardware play into your thinking? Is it all GPU, CPU, or do any of the hardware startups register on your radar currently?
Good, very good question. I kind of terribly suck at the infrastructure and hardware in general, which is probably why I really like abstraction over that. So my answer is, it may be disappointing, but my answer is like, for my own needs, I'm super happy with what AWS provides, and I never had to go anywhere else to get my hardware, you know, my hardware fix. So either like in the GPU sense as well. So most of our work recently is in deep learning. So most of our training actually involves GPUs, and we use, you know, AWS GPU through Metaflow actually, and we don't have much to complain about that. So unfortunately, I'm not super expert in dedicated hardware and so on and so forth. I never use TPUs, for example, because I never use the GCP offering, but I've heard great things about them.
Yeah, great. So, I mean, it's time, Jacopo. I think I had a way of phrasing this question, but Shang Ong's way is fantastic. So Shang Ong, I'll repeat, wrote, I understand reasonable scale is about rethinking companies' ML processes. Let's move into how to actually do it. Shang actually said, for example, Metaflow was mentioned. Could you talk about features or share a case study? I'm wondering if we want to talk more generally about it. And then there is an option. I can share my screen and we can look at like you don't need a bigger boat repo actually to drill down into details. But however you want to approach this and what you think will be most valuable for everyone here.
Absolutely. So yeah, first is, guys, there's an excruciating level of details, which is actually code that runs on like millions and millions of data points. Data is included, by the way, because open source that. So after this call, you can actually go and see like a practical implementation of all of this. So
and that's so you don't need a bigger boat repository.
Exactly. What we're discussing here,
which I've already shared.
It's a bit abstract because we actually don't want to bore you with details that is somewhere else. But to go into a bit more details on, you know, on what we can do is, so I'm gonna tell you practically what happened with Tuzo, my company. My company was like 5 years old, not a million. Okay. And when we set up to build the bigger board repo, what we wanted to do is answer the simple question: what if we need to rebuild Tuzo today? Like, will we do the same choices technical wise to build this NLP company, or would we do something completely different? And the answer, even in 5 years, is we do something completely different. There's not a single tool or a single thing that I did 5 years ago that I would redo now. And so my previous setup was Airflow as an orchestrator, okay, was Spark as our, you know, like distributed engine to kind of compute things. We built this all sort of like, sorry, now I laugh thinking about it. It was like this custom and audible, what we call now DBT. It was like a way to stitch together SQL query in Spark SQL through naming convention, one after the other, to prepare our data, okay? And then you have, you know, custom jobs in Airflow to train stuff. It was pre-deep learning, so at that time we didn't use GPUs. And then you have these audible manual Docker containers to serve your as a serving tool, okay? And it was all clunky and some. I mean, it kind of worked, like, you know, miraculously, but there was a lot of issue with the distributed computing. There was a lot of issues, you know, with the orchestrator, and generally speaking, it kind of felt very not robust. So it was very hard to, when something was wrong, it was super hard to remember, well, which data exactly this model is using, why is it going to run this time, and so on and so forth. And again, this was like 5 years ago, not a million times. And if you look at the bigger bot repo now, none of these things exist anymore. So the entire Spark and distributed computation has been replaced by Snowflake, which is a much nicer experience. Because again, Snowflake, it's a perfect reasonable scale like tool. It abstracts away everything you don't want to do. That is how that is run, distributed computing, and so on. And the only thing it gives you is a SQL interface, and you run just your SQL. And they just do their magic, and you don't even know how they do it, which is amazing. So I don't have to do distributed computing anymore. And the entire orchestration now is Metaflow for us. And so Metaflow really helps you having a pure Python, as we discussed, like a pure Python way of organizing your code. And incredibly so, at every step in which you run computation now, since Metaflow version all the things you have and snapshot that, there's no more this, you know, chasing the data or chasing the bug. If something is wrong, we always know exactly what was happening at every step of our pipeline. And again, for serving, there's a million, you know, SaaS solution you can use. If you just want to stay in AWS, you can use SageMaker, for example. But there's like a lot of different alternatives you can have, which is way better than our finicky Docker container that is hard to scale. You know, every time you inject something, you don't really know if it works, and so on and so forth. Now SageMaker gives you a Python API. You don't even need to have special coding orchestrating that, and so on and so forth. Basically, without even writing almost zero Terraform or the equivalent of infrastructure, like pure code, or if you have to write, you just write it once, okay? And just writing Python or SQL for in the case of Snowflake and dbt, you can basically get the entire company that we built 5 years ago with sweat and tears. You can get it up and running in a week. And if you don't believe me, you can literally go into the repo and you can run it yourself. and you can see that is actually correct. So one person that understands the use case, meaning he understands what the data means, let's say purchases on e-commerce, and understand what he wants to do, let's say a recommender system. This person is empowered without talking to anybody, without knowing any infrastructure at all, to run a deep learning model like the one that we show in the repo from start to finish, and they don't need to even touch any infrastructure, which I think is incredibly powerful. In just 5 years, we went for something that needed a team of data engineer, infrastructure, a data scientist, you know, product person, and so on, to something that basically one person can, you know, relatively easily manage end to end. And I think this is amazing. And I think it changes a lot of what we can do as a team. This is the end-to-end data scientist, right? There's no end-off anymore. Like there's not, hey, there's a data person that ends off the data to you, and now you do the model, and then you end off the artifact, you know, to somebody else that deploys it, right? And now if something goes wrong, he's finger pointing and nobody knows what happens. No. This is a completely different organization. This is an organization when there's some people that build the tooling first, of course. And then there are practitioners that now own the entire feature end to end. And I think this is better for them, is more ownership, more powerful, and it's better for the company, as now people develop this kind of appetite for continuously shift up to production, see the results, and then iterate on that. I don't know
I
if
love this so much.
the level of detail that it was expected. But
it's a great level of detail. I've got a couple more questions, but I kind of want to get into the repo as well. I wasn't intending on doing this, but what I want to also talk about is we're talking about like seismic shifts in how organizations function and as well. And what we're actually figuring out is how to have a principled division of labor. All of these technologies are really new, right? So I always use the analogy, which it's a historical tether that works in some ways, it breaks down in others, but we're kind of like pre-Fortis production line, right? Where they figured out interchangeable parts and started taking everything to the same location, and a lot of people were doing different things. And I'm not suggesting we want a Fortis production line, particularly with the significant implications that has for labor movements. And as a staunch unionist, no, I'm not going to go there. But I do think we are figuring out a principled division of labor, which allows humans autonomy, there's a cybernetic argument of getting humans to work with machines in the ways that are most productive for the humans and for the business, and allowing individuals agency. And as you said, not needing to rely on all these other nodes in the org chart all the time, right? So, and the efficiency gains when you have that type of principled division of labor are inestimable.
Absolutely. I mean, like, consider when we arrived at the company, so it's like a data engineering team responsible for ingesting the data and make sure the data is somewhere in a bucket somewhere, like in the cloud, right? And then there was people doing BI and analytics. They have a copy of that data in a database, and now they have that data, they extract it from there, and they build a dashboard. But now on a parallel line, there was Spark with Scala from ML people doing ML stuff. Okay, and now you have these three teams that technically they're all working with data, but they're not really working together, meaning that it's not like an harmonious process, right? Because then if somebody built, if let's say a person doing BI as a definition of conversion rate, which would be very useful for ML people as well, there's no way these people can communicate. One is on Spark and Scala and reads directly from S3. The other is a copy of that from Redshift and is doing a dashboard in Tableau. These people may actually not even know they're working on the same thing, especially in a fast-growing company. When we grow a lot, and we just hire people, and it's just very it's growth pains, so to speak. So that was the old way. But now let's replace this with the new way. Now there's a single source of truth. In our case, is Snowflake. So everybody reads from the same place first. So first thing that we remove all this data duplication, which also costs a fortune for no reason. Okay. Mm-hmm. And now you can use tool like dbt, for example, to build intermediate feature from the raw data that you ingest to tables that people can digest. Okay. And this table had been written in one language, SQL, that both analysts and machine learning people understand, is in one place, is version, everybody can expect and everybody can work towards it. Which means that now BI people and ML people can build on top of each other, because now they understand these entities and they can kind of share insight or debug them together. And finally, when you put Metaflow in the mix, downstream on top of that, there's no more Scala, there's no more EMR, there's no more anything. There's just Python, and now SQL and Python together goes all the way. So we kind of changed completely this, this view of like, hey, there's a lot of people that really like data and really like to work with each other, but they're kind of stuck in their own language, in their own tribe, and their own practices, to a more, as you said, like a more principled division of labor, when sure, people have the specificity and, there's things that they do and they're good at, but they really build on top of each other. Like the work that somebody's doing is kind of enriching the company in a deep sense, not just doing that specific task, but also be useful for other tasks you may not even know about, when you start doing your work.
Yeah. So before jumping into the repo, we've got a great question from Jeffrey Urban, who's been fantastically thoughtful in this chat. So thank you, Jeffrey. Jeffrey wrote, following up, I love this question actually. Following up on Shang's train of thought, are there examples of tools that are popular because they are used at big company X, but may be counterproductive for a startup or small team?
That's a great question. That's a great question. So I mean, I won't name names, but so there are. Let's put it this way. So I think there's like the thing you should focus when you start a reasonable scale is, the few functional pieces that we mentioned. Okay. There are a lot of cool things that happens in big companies. They may be more geared toward their use cases. Like, for example, like I love feature stores. Like for a company like Coveo, they're like super important. But Coveo is a company that sells ML. Like, we're a very ML heavy company. But I can totally see a company that start this journey of building their first, machine learning like model. They may want, for example, to not do that in the first iteration, and they may want to keep doing something simpler. Okay, so this is, for example, one example. I think they're great feature stores when you grow up with your team and there's a lot of models in production. You really want to use this computation, but it may not be something that you do at day zero. Okay, because especially runtime is complex, like debatable, but you know what I mean. So this is one example of this type of things. And then there's a lot of things in the distributed computing side, which are also kind of typically geared for people that have a lot of data and have a lot of maturity in what they do. So for example, Coveo may be at the end of the day an example for something, but the average ML practitioner maybe not. When you start doing distributed computing, things get immediately more complex. And the truth of the matter that in my experience, in a lot of cases, you don't really need that. You're way better off having a bigger machine or cutting down data, or being clever about your data than going into distributed route, because once you go there, there's a lot of additional complexity and additional cost to keep in mind. So there's a lot of push toward this type of solution for several reasons, and they're great for some use cases like advertising or e-commerce, but there's like a lot of data, but it doesn't mean they are necessarily what people do. Remember, people had a petabyte data a day or whatever they have, you may not have that much. So jumping into a distributed framework, heads on when you still haven't figured out the basic, maybe again a bit premature, and you can always do it later. I hope that's all. That answered the question a bit.
That does answer the question. I think you were also beautifully diplomatic. I will also give it an answer. I will preface this with a few things saying, I feel like I'm on Twitter now, but these are my views, not those of my employer. But I do. So, for example, I'm a huge fan of Kubernetes. Okay, but there is a good question whether practicing scientists should have to interact with Kubernetes on a daily basis. And in my opinion, the answer is definitively no. I mean, I'm talking about the tens of millions of scientists who we want to enable to do modeling and create value for their organizations and businesses and research, right? So the question then becomes and Kubernetes is in Times Square because of, among other, how good it is, but also the amount of mindshare Google has, right? So this is important to recognize. But then the question becomes there are too many verbs. I'm getting too excited here. But the question becomes, how do we get data scientists and scientists access to Kubernetes or Batch or whatever it is, without them needing to mess around with all the stuff we don't necessarily think they should, such as configuration and management and these types of things. And I suppose where that's leading now is a semi-shameless plug for Metaflow, as we talked about before. And there are of course other frameworks that think about this as well. But when you write your flows, your machine learning workflows, you can run certain steps locally. You can provision resources on the cloud to send stuff up to AWS or GCP or Azure or wherever it is, right? And the idea there, of course, is that you can Metaflow has an @batch decorator, Pythonic decorator, of course, and an @Kubernetes decorator, which allows you to provision these as a data scientist without necessarily worrying about everything that happens in the back end. And I think that is actually a wonderful, that dovetails nicely into maybe jumping into the repository slightly. As I said, I wasn't intending on getting so technical, but we've got some minutes left. We may go slightly over. We started a bit late, so we may go slightly over. But Jacopo, if I may do the honors of sharing my screen with, you don't need a bigger boat, and maybe talking through the README, or I can actually do whatever. I'm just gonna make sure that my screen sharing works. Can you see?
I can see your entire screen. Yes, I can see your entire screen.
Great. We're getting some YouTube Inception soon or something. You can see YouTube, presumably.
I can see YouTube. Yes, I can see myself
Okay.
slightly.
You look fantastic, by the way.
Oh yeah.
And by the way, everyone give Jacopo a round of applause, because he was intending on being in the US for this, but he's actually in Europe currently. So it's 2 a.m. or something for him. So definitely when I see you in New York, dinner and drinks are on me, an espresso, because you may need more of that.
I mean, thanks again for spending time together. It's an honor and pleasure to be here.
This is so much fun. So yeah, this is so I'm going to link to this in the chat one more time. And yeah, so maybe you can talk us through a few things here. Where would you like me to scroll to? Or
like if you just maybe go to the image, I think that's perfect. Like So, but I want you to say two things first. Like, why do we do this? So there's a lot of tutorials already like around, and honestly, also we're not an MLOps company. We do something completely different. And so tutorials typically have two features. One, they explain you one tool at a time. So they explain you Metaflow, they explain you, like dbt or Prefect or whatever. And of course, for good reasons, because, want to introduce, tool A or tool B. And then the second thing the tutorials do is they typically use toy example. Like maybe it's a data set that is created with 2 lines of NumPy, just to, or, just like I don't know, like, like
the iris.
The iris, or like the Titanic data set, right? Like the time that all these data set, of course, like all good and well, but they're not really representative of real life. So this thing here kind of tries to get away from these two principles. So first, we're not going to show you one tool. We're going to show you like how several tools that are all good in their own respect fit together into a pipeline that goes literally from raw data that were ingested at some point by the company from real browsers of people shopping online, completely anonymized and blah, 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 okay, to an endpoint serving almost state-of-the-art model. It's a transformer recommendation model, so pretty advanced model in recommendation, okay? So this is end-to-end, and all the tools stitch together nicely, okay? And the second thing that we do is, it's not a toy example. Like, this is a real recommendation that you can actually use for real in your life, and it's going to be pretty competitive. May not be Alibaba competitive, but as you said, at reasonable scale, this is actually pretty good. And the cool thing is that you can run it basically by yourself. Like, once the setup is done, all of this thing can be run by a data scientist, and you can iterate on this basically by 1 or 2 people. So it's really, really effective if you think about it. So that said, so this is kind of like what you will find in the code that you can run, okay? So these are all the tools that we pick and choose for this example. These are not the only one, and and I don't represent like Twitter moment. This view don't even represent my own view. This is one example of the puzzle that you can make.
Well, be careful. It's actually 2 examples. And I think this is when we're talking about baby steps, when, I mean, I was thinking, you got to walk before you can run, but you got to crawl. And so maybe starting to crawl with, you've got a data warehouse version, but you also have a Metaflow only version, right?
Absolutely. Yeah. So yes, yes. Very good point, Hugo. So this is the full version of this repo. This repo comes in 2 flavors. There's a simplified version that doesn't involve Snowflake if you don't want to use it. And you can just use it to kind of like, get your feet wet with Metaflow and kind of the basic concept of the functional pieces that are needed to build an ML pipeline that is actually production ready. That is actually what real professionals do. And then once you get comfortable, you can go to this picture. But I was like, this picture shouldn't be taken as the crystallized example of what I think or anybody's think as the best thing. But it's one way in which you operationalize these steps. You see here all the steps, and one way in which to make them like vivid and to make them like work
absolutely
together. So,
and to be clear, all of these tools here are interoperable as we've seen, but swap outable as well. I mean, let's say your company uses Comet ML and not weights and biases, for example, right? Then you switch that in or switch it out, or you're using some bespoke like PyTest instead of great expectations, right?
Or dbt test, like there's a plugin for dbt that just test, for example, dbt test, or using Tableau instead of preset. Like you're like all of this is mostly changeable. Okay, so all of this is mostly changeable for things that there's always room to debate if tool A is better than tool B, But what we're trying to convey here, and again, we're trying to convey with working code end-to-end, is there's some invariance of how you build a system that works, and this is one implementation of it. If you think of like classes and implementation in the programming sense, right? So what we're trying to show here is both as a template with the functional level, and then a practical implementation of this function in some pieces of code that actually work. But of course, again, if you want to change A or B, it's fine. There are some things that we believe are more fundamental than others, and we wrote extensively about this. And the two fundamental pieces is where computation happened for us. So it's Snowflake on the data ops side, and it's Metaflow on the ML side. So these for us are the fundamental pieces of this thing, because it's where actually things are run. But that said, everything else it's important as well. As in, if you want to, again, I wouldn't suggest people to start with the full picture, but once you get your feet wet and you start getting your results, then you're kind of also getting very excited and you want to do more. And then at that point, you want to add new tools and so on and so forth.
Someone just said the sound has gone dead. I'm just going to check. I
could hear you fine, but can you hear me?
I can hear you, and I just saw that in the chat, but I think it was just I just tested it, and so I'm just gonna type is sound working. I'm pretty sure it is.
I think so.
Yeah, I think we're good.
Awesome.
Sorry about that. Michael Neely actually has a fantastic question again. How easily interchangeable are these things? I assume there aren't standard interfaces. I have a slight answer to that. The thank you, Ville, for saying the sound works. First love, oh yeah, lots of sound. Sound channeled globally. How easily interchangeable? This is a beautiful question. Because I don't, there's significant variance, but I think some of the products and open source frameworks that are rising to the surface, the question is really about levels of abstraction and API design, right? And I think, we are figuring out the foundations of how these things are interoperable and how they connect. And I think we've actually learned a lot of lessons from AWS as well about how things should and should not connect and be interoperable. But maybe you can say a bit about how interoperable these things are and how that relates to the level of abstraction.
I think a lot. Like if you put some thoughts into how you implement them, then it's basically going to be easy for you also to try it out, like tool A or tool B. Like Hugo was making a very good example with Comet. So if you see the repo, there's actually an abstraction that's generic, like sour generic. It's not final, but it kind of allow you to experiment with different experiment tracker. And so you can choose the one that suits your needs the most, for example, proving that these things are pretty interoperable, one with each other. Metaflow, when the computation runs, it's pure Python, meaning that everything that is kind of Python compatible can actually be put there. So I mean, we run all sorts of things inside of Metaflow, and it runs because it's just pure arbitrary Python. They can add whatever they want. So that's also kind of very compatible with anything you want to add, SageMaker, or you want to train in PyTorch or Keras, whatever, do whatever you want. And on the data side, if you stick to SQL, I mean, anything that will speak to Snowflake can do the job of data aggregation and data preparation as well. So I think a good thing about simplifying the entire thing to two languages that most people speak, and then most tools have SDK for, or that are interoperable with SQL and Python. I think this new ecosystem of tools is actually way better in so far as avoiding vendor lock-in than your typical monolith BIM of 5 or 6 years ago, when you're kind of stuck. You have to get something and you're kind of stuck in it for all of that.
And I think it's also probably just important to say, when thinking about interoperability, even before interoperability, like individual, like backwards compatibility or lack of backwards compatibility of individual packages, right? You will have over 1,000 paper cuts weekly currently. And I don't mean to scare anyone too much, but I think, we work on paper cut reduction. We think about that a lot. but it's still a part of the job. So thinking about, and maybe we talked about this, I was using the SageMaker SDK recently, and the version of scikit-learn that it required mismatched with one that I was using locally, and I wasn't, the error message, anyway, it was like, this took a day and a half to figure out something that maybe an error message could have helped with. But even slight, versioning and dependency challenges plays a huge role in this idea of interoperability, I think, as well.
Absolutely. I also think that SageMaker API could use some working. I mean, I'm a user, like I use it, but I think it's not the most. I mean, like sometimes AWS PaaS services are not the most, like, say, intuitive to start up. Once you get a hold of, like, once you get the grip of how it works, like, it's fine. But the first few days is not always rocky, in my experience, in the SageMaker side of things.
Once again, I am inspired by and appreciate your diplomacy, Jacopo. I actually was, let's say, maybe complaining is a weak version of the term, to our mutual friend and colleague Ville Toulos, who develops Metaflow and is CEO of Outerbounds. And I was complaining about some of the issues I was having with SageMaker, among other things. And he said to me very gently and kindly, as is Ville's want. He said, I totally understand the pain, and it's really challenging. But Hugo, you must remember that it's only 15 years ago that we started having these in our pockets, and now you're able to deploy a machine learning model globally, right? So, like, the fact that we have paper cuts is incredibly frustrating, but remember where we've come from, and where we are currently. And I think that framing it like that, it doesn't. I mean, I still feel the pain, right? But that definitely helps in terms of kind of resetting my expectations. So it's time to wrap up. I would love everyone who's we've got a lot of great questions that we don't have time to get to now, unfortunately. But if you join us on our community Slack and join the AMA guests channel, we'll be there for the next week or so. I'm just sharing that link once again in the YouTube chat. But Jacopo, I'm just wondering if you have any final words of wisdom. Well, all your words are wise and hard-earned as well. I mean, you emerge from the battlefield of reasonable scale ML to tell us what it looks like in there, so we can put on the correct armor. And I'm wondering if there are any final thoughts or words of advice that you've learned the hard way that will help get people started with reasonable scale machine learning.
So the first word of advice is ask. Like, ask to the incredible folks at Outerbounds in Slack, ask to me, or hopefully better people. But like, don't be shy. There's a lot of people that are really great in this community, and they want to give back and kind of avoid, some of the pain that they had to you. So don't be shy. There's no question that is too dumb or too simple. It's new for everybody, and so please do reach out if you think that we can be of any help. That's really important to me. And the community is amazing. Like, the best thing about the MLOps so far is not the tooling, which are great but evolving. The best thing so far that I found in this community is the people. And they're super great, great builder, but also great at kind of encouraging everybody to kind of get the most out of it. And I think there's no real concept of like competition or there's a lot of tools, but I think if we make the field better altogether, if you raise the level of discourse altogether, everybody's gonna benefit from it. And I really believe that. So that's the first thing. The second thing is that don't get discouraged by the fact there are like 25,000 millions, dozen billions of tools out there. Again, if you want a list to start with, you can start with ours, and that's fine. But the general thing is, don't get decision paralysis. Start with the 3 things that you need to get one model out in production and measure whatever impact you have on a tiny scale. Like, don't be reckless. No, if your model is about health or something like that, please, do your test and so on. But like, a lot of models, especially in the enterprise, are not really live for that situation. And speed of iteration is the most important thing. So get 2 or 3 tools, 3 open source stuff that that you want, that do the 3 things that we discussed. Data, training, and serving. Start getting feedback results, iterate on that, and then build from that. Don't get a paralysis of wanting to get the entire tool chain right first, if for whatever reason you're not an expert in this or you don't have access to an expert in this. Okay, yeah. Start by closing the feedback loop. Closing the feedback loop is the most important thing. And Metaflow is like incredible for doing this. It will shorten your feedback loop, but like a lot, if you just start, reasoning like Metaflow wants you to reason. And after you get the hand of it, then you can even, you can complicate things as much as you want, but get to the end-to-end slice as soon as possible when you do machine learning. Because until that thing is not deployed, you don't have anything. You don't have really anything to show for it. It's not like software.
Yeah.
If it works on your computer, it doesn't count. It needs to be having an impact in the world.
It's so important. And so I just want to reiterate those two things, community and communication, which I want to say a word about in a second, and then closing the feedback loop, being agile and moving as quickly as possible. And the latter, I think, is actually, both are incredibly important, but the latter is amazingly important and harks back to a question we had around competitive edges against larger companies. And as a smaller, reasonable scale company, one of your most important competitive edges is your ability to move quickly in a way that larger companies don't. So make sure you do that. And I mean, straight from Jacopo's mouth, definitely check out Metaflow if you think it would serve your needs. The community and communication, I really appreciate you calling out, and that's one of the reasons I love working in this space. And I do think I'm very grateful to have the opportunity to, as part of my work, have conversations like this. The fact that we're linking people to a repository. I mean, we've got code examples, we have blog posts on Medium, we have conversations like this, we have conversations on Slack, on LinkedIn, on Twitter. The fact that we have a whole variety of modes of communication to figure out what our industry looks like and what best practices are emerging. I think it's such a wicked challenge, so to speak, that we do need to approach it from all these different angles. And I hope that conversations like this, in addition to all the code and getting you up and running technically, are helpful for everyone out there. So to close up, definitely come and join us on Slack to chat more over the next week. Very grateful for you all joining us today. Incredibly grateful for your expertise and time, Jacopo. And I always love chatting with you, as you know. So thank you once again.
Thanks so much for inviting me, and thanks to everybody again for preferring this to a tennis match. So
fantastic. Yeah, exactly.
I wouldn't have done it if I were you. I wouldn't have done it. So yes.
Yeah. Exactly. Awesome. So we'll see you all on